NASA's billion-dollar investment to create the most powerful telescope in history is serving its purpose by providing us with exciting new insights into the early stages of the universe and our own origins. Recently, researchers have discovered 6 megagalaxies that formed in the early universe when it was a hot, dense mixture. The James Webb Space Telescope has continued to explore and examine these discoveries, and each observation reveals even more distant and ancient galaxies, each with unique characteristics. However, the most striking discovery is the detection of volcanic material, including the building blocks of life, in one of these ancient and primitive galaxies. This represents a breakthrough that transforms our understanding of the cosmos. Join us as we explore this incredible discovery made by the James Webb Space Telescope and what it could mean for our future. If you're interested in keeping up to date with views from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Astronomers using the James Webb Telescope have succeeded in detecting the most distant organic molecules known in the universe. This is the first time complex molecules have been found in the distant universe. These complex molecules were found in a galaxy called SPT 0418-47, located at a distance of more than 12 billion light-years. Given that the universe is approximately 13.7 billion years old, this galaxy is extremely old. The structure, which resembles a cosmic smoke ring, reveals the presence of complex organic molecules similar to smoke or smog. This discovery provides information about the chemical interactions that occurred in the earliest galaxies and their relationship to star formation on Earth. These molecules, known as polycyclic aromatic hydrocarbons, are found in smoke, soot, smog, engine exhaust, and forest fires. Organic molecules are based on carbon, which is considered one of the building blocks of life, as it is an essential element in the amino acids that make up proteins. Light from this dusty galaxy began its journey across the cosmos when the universe was less than 1.5 billion years old, which is only 10% of its current age of 13.8 billion years. Using the James Webb Telescope's infrared capabilities, which can detect light invisible to the human eye and penetrate cosmic dust, new details about the galaxy were captured. In addition, the Space Observatory benefits from a phenomenon known as gravitational lensing. This phenomenon occurs when two galaxies are almost perfectly aligned from our perspective on Earth, causing the light from the background galaxy to be deformed and magnified as it passes near the foreground galaxy, forming a ring known as an Einstein ring. Gravitational lensing was originally predicted by Albert Einstein in his theory of relativity. Thanks to this increase in magnification, we can observe in detail the components of a galaxy in the early universe that we could not otherwise see. During a thorough analysis of the data from the Webb telescope, astronomers detected the signature of organic molecules in an unexpected way. This surprising discovery is helping astronomers answer some of the most fundamental questions about the origin of the universe. It is amazing that scientists can identify molecules located billions of light-years away that are similar to those we know here on Earth, but are often associated with undesirable forms such as smog or smoke. Since its launch, the James Webb Telescope has been in the news for its observation of miles of colossal galaxies. Now, the James Webb Telescope has made shocking new discoveries that could completely change our understanding and require a thorough overhaul of all of our cosmological theories. These groundbreaking discoveries could have a significant impact on our current knowledge. Continuing its series of discoveries questioning the Big Bang, the James Webb Space Telescope has found the most distant cluster of galaxies ever observed, at a distance of 30 billion light-years. According to researchers, this cluster is possibly one of the largest in the universe today. Although the 7 galaxies that make up the cluster had previously been observed with the Hubble Space Telescope, scientists did not have precise information about their distance or whether they were actually bound together as a group. because of the time it takes light to travel from these distant objects to the position of the JWST telescope in orbit around the Sun. We are observing these galaxies as they were approximately 650 million years after the Big Bang. The present form in which we see the protocluster gives the impression of being small. However, if we could observe it instantaneously without the limitation of the speed of light, it would most likely appear colossal, capable of exerting a gravitational pull on thousands of galaxies. Simulations by researchers suggest that this protocluster could be one of the largest clusters in the universe today. Recently, the James Webb Telescope also made a surprising discovery when it found a tiny galaxy that existed 13 billion light-years ago and has been developing stars at an exceptionally high rate relative to its tiny size. This is believed to be the smallest galaxy ever discovered at this distance, approximately 500 million years after the Big Bang. In a groundbreaking finding, a team of researchers from the University of Minnesota took the James Webb Telescope to peer more than 13 billion years into the past and discovered an extraordinarily tiny galaxy that has been developing stars at an extremely fast rate given its dimensions. This tiny galaxy is one of the smallest ever discovered at this distance, just after the initial explosion of the universe, and has the potential to help astronomers better understand galaxies that existed millions of years ago. This galaxy is beyond the capability of all telescopes except the James Webb, and the first observations of this distant galaxy are truly impressive, said Patrick Kelly, lead author of this study. Although the galaxy is about 1/1,000,000th the volume of the Milky Way, it is amazing that it continues to form the same number of stars each year. It's a fascinating phenomenon. If you're wondering how the James Webb Telescope can observe such minute details in a field wide enough to capture the entire galaxy, don't hesitate. The field of view of the legendary James Webb Telescope is wide enough to capture the entire galaxy cluster at once. This is mainly due to a phenomenon called gravitational lensing. Gravitational lensing uses lenses that bend and magnify the light from the mass present in the galaxy or galaxy cluster. Gravitational lensing has played a crucial role in making this small galaxy appear 20 times brighter than it really is. In fact, this may be the first time we have had the opportunity to observe such a distant part of the universe, almost to the very moment of the Big Bang. The James Webb Telescope, with its exceptional ability to track galaxies, has made this task easier than ever before. Until now, we have had only 2 space observatories capable of creating deep-field images that allow us to see the universe in unprecedented detail: Hubble and James Webb. Hubble operates in the visible light range, while Webb focuses on the infrared. Although both capture images of distant galaxies in dimly lit areas of the sky, Webb's images are sharper because of their infrared capabilities. When we compare the deep field captured by each of these telescopes, we can appreciate the remarkable differences. The Webb images have their own distinctive look compared to those from Hubble. This is most evident in the appearance of the stars, with their distinctive pointed diffraction peaks. These peaks are unique features of the Webb images because of the shape of its mirror. Webb's ability to observe objects in the infrared gives it a significant advantage over other space telescopes, including its predecessor Hubble. Many objects that remained hidden or inconspicuous in Hubble's deep-field images are now being revealed, literally, by Webb. If things turn out this way, 2023 is likely to be full of discoveries that will change our understanding of the cosmos. But who can predict with certainty what is to come? Thank you very much for watching the video. Remember to like and subscribe, and we'll see you in the next one.